What's up everybody and welcome to a new video. And in this video we're going to start working on the additional features for our Minesweeper game. And the first one is that we want to use colors to indicate a win or a loss. So to demonstrate what I mean by that, let's again run our game and then here let's lose it. Namely, then it just says here you lost and then that's it. And now what I would like to do is I would like to print here this message then in red as well as this header here and then also here the border around our grid. And if there's a win, then everything should be printed in green. So that's what we're going to do now. And therefore we're going to need another NC escape code. Namely, we're going to need the one for the color green. And then we're also going to need a new constant. Namely, we're going to replace here this game state messages constant with this new game states constant. So it's also a dictionary. So here then, if the game state is a win, then the color is green and the message is you won. If the game state is a loss, then the color is red and the message is you lost. And if the game state is active, then the color is going to be the reset. So it's just going to be the default color of the terminal. So now what we're going to do first is we're going to adjust the code for this message here at the bottom. So therefore, let's go into game.py and then let's go here to the place where we print out here this message. And first, let's adjust here our code for the respective message that we want to print. So in this case, then the new constant is called game states. And then we're going to say here brackets game state. And in this case, then we want to have the respective message. And then once we have that message, we can now apply here the color to this message variable. So therefore, we're going to simply add that color. So we're going to say h.gameStates, then brackets game.state. And then here again brackets, and this time we want to have the color. And we're going to add that to our message. And then at the end, we're going to use the reset NC escape code. So we're going to say here reset. And that's already it. So now let's see if that is working. So let's run the game again, and then let's lose it. So if I now lose it, you can see that now our message here is printed in red. So now let's see if that also works when we win the game. So therefore, let me just here reduce the number of mines down to 1. Then let's run the game again. And now if I here win the game, it now says here you won in the color green. So this is working. So now let's do the same thing here for the header and then also for the border around our grid. So therefore, we need to go into our show grid function. And then here is our header. So here we're going to do the same thing. So we're going to add here the color to our header. So we're going to say game states brackets self.state. And then here we want to have the color. So we're going to add that. And then at the end, we're going to again add the reset. So we're going to say here plus reset. And then we also need to do that here for our border. So basically we can just then copy this and then we need to add it here for the upper border, then here for the left border, then for the lower border, and then also here for the right border. And then in all these cases, we then need to add here also the reset. So let's add it here, here, then here for the right border, and then here lastly for the lower border. So now let's see if that is working. So let's run the game again. And now let's here win the game. And now as you can see, the header is printed in green, this message, and then also this border around our grid. So now let's see if that also works when we lose the game. So therefore, let's set the number of mines back to 10. So let's run the game again. And then let's lose it. So now we lose it. And then here, as you can see, everything now is printed in red. So our code is working. And therefore, then we can check off here the next point in our to-do list. And then the next to-do is that we want to provide different difficulty levels. So currently our grid always has 9 rows, 9 columns, and 10 mines. And we would like the player to be able to choose between different difficulty levels so that we can then have here different values. So therefore then I've prepared here a new constant. So this is called difficulty levels. It's again a dictionary, and here the keys are E, N, and H. So it stands for easy, normal, and hard. And then here the grid size for easy is 9 by 9, for normal it's 16 by 16, and for hard it's 16 by 30. And then the number of mines is 10, 40, and 99 respectively. So now we need to ask the player what difficulty level he or she wants to play. So therefore we're going to create a new helper function. So therefore let's go down here at the end of this file. And then here we're going to create a new function, and we're going to call this ask difficulty. And this is basically going to have the same structure as this play again function here. So here then we're also going to say wire true. And then here we're going to say difficulty equals input. And then the prompt is going to be the following one. So we're going to say choose a difficulty, easy, normal, or hard. And then here we're going to say if difficulty in difficulty levels. So if it is a key in this dictionary, then we want to simply return that difficulty. Otherwise, we want to again give here some feedback. So we're going to say give feedback. And here the feedback message is the following. So we're simply going to say, please enter E, N, or H. And then we're also going to set here the delay parameter equal to true. So that's our ask difficulty function. And now we need to call it. And we're going to call it in our init method, namely right here at the beginning, before we then here create our grid. So we're going to say here self.difficulty, and it's going to be equal to ask difficulty. And then we can use this self.difficulty here to access the respective values in our difficulty levels dictionary. So then here we're going to say self.nRows, self.n columns. This is going to be equal to difficulty levels, bracket self.difficulty. And then here we want to have the grid size. So we're going to say grid size. And then we're going to do the same thing here for the number of mines. So we're going to say self.n mines equals difficulty levels, bracket self.difficulty. And then here we want to have n mines. So this is now our new init method. And now what we need to do is we need to replace here these constants here in this file, always then here with these new attributes. So that's what we're going to do now. So let's here use the search. And then I'm going to use here the match case toggle. And then I'm going to replace n rows with self.n rows. So let's replace all instances. Then we can get rid of this here in this place. Then we're going to do the same thing here for the columns. So we're going to say n codes, replace all. Then we can get rid of this. And then lastly, we're also going to do that for the mines. So we're going to say here n mines, and then replace all these instances. And then we're going to get rid of these lines here. So then we also need to do that here in game.py. So here we're going to then say, instead of saying h.n mines, we're going to then replace that with game.n mines. So let's replace all. Then we're going to do this also for the rows. So game.n rows, replace all. And then lastly, also for the columns, let's replace all. And that's it. So now let's see if that is working. So let's run the game again. We're going to say game.py. And then here we are asked what difficulty we want to play. So choose difficulty, easy, normal, hard. So let's first provide a wrong input. So let's, for example, provide here an F. So if I press enter, then it says, please enter E, N, or H. So now let's choose here easy. So let's press enter. Then now we have here our easy game board. So let's now here lose this game. And then play again, yes. And now let's pick normal. And then as you can see, we have now a bigger grid with 40 mines. So now let's again also lose that. And then play again. And now let's pick here hard. And then here as you can see, we have now the biggest grid with 99 mines. So our code is working. And therefore then we can check off here the next point in our to-do list. Then the next to do is to ensure that the first move is free. So currently what we are doing is here in our init method, we are already calling our place mines method. So that means we are placing the mines before the player makes the first move. So therefore then with the first move, the player can already hit a mine and then the game would already be over. So for example, to demonstrate that, let's set here the number of mines here for the easy mode to 80. So there's then only one free cell. And then let's run the game again. Let's pick easy. And now let's here play, for example, the cell. And then as you can see, this is already a mine and then the game is already over. So now what I would like to do is I would like to ensure that the first move here is free and I want to start here just with a single cell. So therefore then what we're going to do is we are not calling here place mines within init, but instead we're going to call it here in game.py. Namely, we're going to call it here in this reveal cell section, and we're going to call it here before the flood fill algorithm. So then let me here write out a comment. So this then says place mines only after first move has already been selected. So now to implement that, what we're going to do is we're going to need here, or we're going to create here a new attribute. So we're going to say here self.first move equals true. And then here in game.py, we're going to say if game.first move, only then we want to place our mines. So we're going to say here then game.place mines. And then after that, we're going to set this first move parameter attribute equal to false. So now what we need to do is here with this place mines method, we need to make sure that we don't include here the cell that the player wants to play. So therefore then we need to know what cell it is. So therefore then we need to pass in here the game.cursor row and then also the game.cursor column. So now let's adjust here the definition of our place mines method. So therefore let's go here to helpers.py and then here's place mines. So let's first add these new parameters. So we're going to say here row and column. And then here what we're going to do is we're going to create here a new variable, and it's going to be called eligible cells. And here we're going to use again a list comprehension. So here we're going to say for cell in all cells. And then here we want to have that cell, but we only want to have it if that cell is not equal to the cell that the player wants to play. So if it's not equal to here the row and the column. And then we're going to sample here simply from this eligible cells variable. So this that's already it. So now let's see if that is working. So therefore let's run the game again. So let's pick easy mode. Again, we have here 80 mines. So now let's play here this cell. And as you can see, now we already won because there's now only one free cell. So maybe that was luck. So therefore let's run here again. And then let's play easy mode. And then let's play here a different cell. Let's play this one. And again, it's free. So our code seems to be working. So therefore then we can check off here the next point in our to-do list. Then the next to do is to create a whole safe zone. And to explain why, let's again run the game. And this time we're going to play here hard mode. And here sometimes what can happen is that if you reveal here a cell, is that you only reveal here a single cell. And this doesn't give you much information. So therefore then I want to create here the safe zone for the first move so that we maybe then more easily trigger the flood fill algorithm and then get here more information. And the safe zone is going to be the cell that the player wants to play and then all surrounding cells. So this is now what we want to implement. Therefore then here in our place mines method, we're going to create a new variable and this is going to be called safe zone. And as I just said, the safe zone is going to be the cell that the player wants to play and then all surrounding cells. So therefore then we can use here this get surrounding cells method. So we can here say self.get surrounding cells. And then here we put in the row and the column. And here then, however, the way that we designed this get surrounding cells method is that we didn't want to include the center. And now, however, for our place mines method, we want to include the center. So therefore then we're going to add here another parameter and we're going to call this add center, and by default this is going to be false. So then here in this if statement, what we're going to do is we're going to simply say and not add center. So only if we don't want to add the center, then we're going to continue to the next iteration of this for loop here. So then here in our place mines method, let's then set this add center parameter equal to true. So we're going to say here add center equals true. And then to determine here these eligible cells, what we're going to do is we're going to say here if cell not in safe zone. So we want to have all the cells here from this all cells variable, but only the cells that are not in our safe zone. So this is now our code. So now let's test it. Therefore, let's set here the number of mines in the easy mode to 72. So therefore then there are only 9 free cells. So this should then be our safe zone. So now let's see if that is working. So let's run the game again and then here easy mode. And now if I reveal here the cell, we should already win because we are gonna reveal here all these 9 cells and those are the only 3 cells available. So now let's press enter and see what happens. And as you can see, we've already won. And again, maybe this was luck. So therefore then let's just try it again. Easy mode. And then let's play here another cell. Let's play this one. Let's press enter. And as you can see, again, we have won. So our code seems to be working. And now let's then actually set the number of mines back to 10. And then another change that I want to make here is that now in this place mines method, we are using here this get surrounding cells method. So therefore, let's actually put this get surrounding cells method in front of the place mines method. Okay, so this is now what I wanted to change. And therefore, then we can now check off here the next point in our to-do list. And with that, then we've covered here now this whole section for ensuring that the first move is free. So then in the upcoming video, we're gonna then start working here on the section where we want to track the high scores. So thanks for watching and hopefully I will see you in the next video.